Hey, good morning, guys. How are you? I'll take my glasses off because there's so much glare. Man, I need a haircut. Boy, I'm gonna get that done soon once this quarantine's over, right? Anyway, boy, I do that too. Hey, I hope you guys are doing okay. I hope everybody's safe at home. Everybody's well. Nobody's going too stir crazy, and all that. So yesterday we tried to do a quiz on using Google Forms, and um, well, I didn't proofread one of my answers and I had a mistake. I did have an I don't know option, so if you selected that for those problems, you got it right. A couple people reached out through email and asked that we go over some of the questions, and so I have a copy of the quiz right here, paper copy, and well, let's go over it, see how it is. And then after that, there's a couple things, a couple heads up for some other things that are going to come out today, and well, we'll go from there. So I'm hoping you're making good use of this. If you're not, that's fine. But for those of you that are kind of bored at home and you still want to see how well you can do on that IGCSE test, I'm here to help you guys out. So let's get to it, shall we? I'm going to go ahead and flip over to the document camera, slap the glasses back on. Here we go. All right. It should be nice and clear. I got a nice light set up, so should be okay. So I already started this, and then I had a problem with the video, so I stopped it and had to start over. But let's go ahead and take a look. So it says right here, make sure when you're doing these things, as you guys know, you've got to read it, right? So you got to read it. You got to make sense of all the information. You got to look for what clues are there. See my nice thumb bruise? Oh man, I'm not used to working with my hands. Anyway, it says ABCDE is a regular polygon with the center, I love how the British spell center, of O. So A, B, C, D. And so it says, what's the special name for this polygon? Well, there are 5 sides, so that's a pentagon. You could also say a regular pentagon if you wanted. Doesn't matter. Now, angle EOD. I already have the calculation here. But the thing is, if you didn't get that, then there's a key piece of information you didn't identify. You didn't identify what kind of angle this is. This is a central angle. Central angles add up to 360 degrees, and the number of central angles in a polygon is the same as the number of sides. So 5 sides, the sum is 360. All you got to do is divide, so you got 72 degrees. Right? Now, next thing, we got to calculate angle AED. That's this area here. The thing that you've got to recognize about AED is an interior angle. Now, when we learned about this the first time, we went ahead and derived the formula. We showed where the formula came from, but there are basically the number of sides minus 2 is how many triangles you can, on-overlapping triangles you can make inside of this, right? So, and each triangle is worth 180 degrees. So I give you the sum of all the angles, but we're looking for 1. So this is how you can find the measurement of an interior angle of a regular polygon with that formula right there. Of course, n is 5, so 180. Let's go ahead and write our formula out, plug in our numbers correctly. So that's 3, right? 180 is divisible by 5. So let's go ahead and do that. 5 goes into, I think it's going to be, 5 goes into 18 3 times with a remainder of 3. 5 goes into, there we go. So 36, 8, 1, 108. So 108 degrees. Now if this was a paper 2, you'd have to do the calculation on paper like that. If it was a paper 4, you could use a calculator. If you wanted, you could use a fancy calculator like this. But even so, here's what I'd like to share with you. I would not plug this in. I would say 180 times 3 and hit equals and then divide by 5, just to make sure that you're not going to mess up the order of operations by using your calculator incorrectly. So anyway, there we go. First page done. Second page. All right. Now, once again, you've got to make sure you read all the information, that you understand all of the information, then you're using all the clues provided in order to answer the question. Because if you're missing any one of those things, you're probably going to mess it up. I don't know why this document camera is very well focused on one side. Like over here it's pretty well focused. Over there it's not. Oh well. So it says in the diagram below, AB and CD are straight lines. AB and CD are straight lines, and they intersect at M. I don't know if you guys remember this. We did a problem last semester where there was one of these lines and it looked straight, but it wasn't. It was off at a little angle. So here it's telling us they are straight and they intersect there, right? LMN is parallel to QRS. So these two are the parallel lines that makes these transversals. This is 35, that's 64. All right, we have to find the measurement of angles X, Y, and Z. So the three ones. Now, let's talk about why each one is. So I know that X for sure is 35 degrees because it's a vertical angle. We weren't asked to justify, but if we were, that's the reason why that we know that X is 35 degrees. It's vertical. Now, angle Y. Let's see. There's a couple ways we could go about this. Angle Y, you see angle Y right here and 64 degrees right here. Those are alternate exterior. So I'm going to go ahead and say that that's going to be a 64 degree angle. I think we're going to have a check for that in a minute, but we'll see. All right, now, angle Z. Let's see. Angle Z, and this one right here, those are going to be these right here are corresponding. Lost the word. I've been out of school for 2 weeks and I forgot everything too, and I have a math degree. Isn't that embarrassing? Oh well. Such is life, right? So anyway, this angle and this right here are corresponding, so they're in the same relative location, right? So let's go ahead and draw a little diagram of that. Let's see, that's LN, and this is PS, right? And this is DC, right? So what we have right here is we have this angle right here and this angle right here. They're going to be the same, right? Now, we can figure out this angle right here because this is a straight line. AB is a straight line. So these three have to add up to 180. So this plus this have to equal 180. So 180, and then minus the sum of those two will be what we got. So let's see. That's going to be 91 minus 180. So that's going to be 89 degrees. I think that my math is right there, right? Let's go ahead and double check. Let's see. Because when you do a paper 2 or a paper 4, you're going to be well versed. You're probably going to have a little extra time. So, you can go ahead and double check your arithmetic. So that's a 9. Oh, and a 9. Ah, look at that. Now look at that. 81. I didn't even do that on purpose. I promise I did not even do that on purpose. So double checking your arithmetic is a really good idea because it's really easy to make an arithmetic error like that. And so just doing it twice to make sure is good practice. All right. Now this one right here. Calculate the circumference of a circle that has a diameter. Diameter. So circumference is pi d, or the one we most often use is 2 pi r. Right? Circumference is the distance around the outside. The thing you guys are typically doing is you're mixing up these two right here, and so I see a lot of you guys having some nonsensical thing like this, which is the area of 2 circles, because this is 1 circle. That'd make 2 of them. So anyway, there we go. It's just going to be 13 times pi. That's all. I don't even know why that's worth 2 points. Since it's in centimeters, yeah, makes no sense why it's worth 2 points, but it is. All right, now, this one. It says ABQ is a semicircle. That's super important because that means if you found the midpoint right here, that's going to be the center of the circle. Semicircle cuts it in half, right? That makes this the diameter, okay? The reason that's important is because if this is the diameter, that means this is a right triangle, because any triangle that lies on the diameter it's inscribed is going to be a right triangle. All right, so that's 33, and that makes this one's going to have to be supplementary to that, so this is going to be 57. Now let's just go ahead and make sure. 57, 33, it's easy to make silly mistakes. There we go, 90. Boom, done. All right, so the angle ABQ is what we're supposed to find out. We found out that it's 57 degrees. All right, now, man, the queen of the ball right here. This is what most people had a question about. That blurriness on the side over there is really bugging me. I don't know why it's blurry over here. fairly clear over there. Oh well. Uh, let's get to it, right? So it says we have a parallelogram right here. Parallelogram means that PM and OQ are going to be parallel, and OP will be parallel to sorry, I don't know if I said that right. OP will be parallel to QM. PM will be parallel to OQ. All right. And it looks like we have a diagonal right here, Q to P. And we are told that O is the origin. So if this was on a coordinate plane, that would be the origin. That means we're going to have some position vectors we could use. All right. And then it says OP is the vector P. Okay. OP is the vector P. And OQ, oh, there's a typo here. This isn't my mistake. This is actually a mistake from the software. So OQ is the vector Q. All right. Sorry about that. That's weird. Huh. All right. Now, because I didn't write this, that's the kind of thing I would do all the time, right? Now it says L is on PQ such that, PL to LQ is 2 to 1. PL, so from PL to LQ is such that the ratio is from 2 to 1. So that means that Q to P, if you multiply that times 2/3, that's going to be P to L. And if you multiply Q to P by 1/3, that's going to be Q to L. All right, because there's 3 parts. This is 2, that's 1. Right, so this is 2/3 of it, of the distance from P to Q. This right here is 2/3. And from here to here is 1/3 of this total distance. The reason I know that is because of this proportion right there. All right, now find the following vectors in terms of P and Q. Write your answer in simplest form. Find the following vectors in terms of P and Q. Write your answers in simplest form. So P to Q. So P to Q is from here to here. So how can I go from here to here using these 2 vectors, right? So a vector is a distance and a direction. So I'm starting here, I'm ending there. I don't know how to describe this directly, but I do see that if I went from P to O and then O to Q, I'm using those 2 vectors. Now with the vectors, you can make them smaller by multiplying by a fraction. You can change the direction by multiplying by a negative number. You can make them longer by multiplying by a positive number. You can add them. So if I change the direction of this, that would take me from here to here. So this is going to be Q minus P. You could also do negative P plus Q, but I think this is less likely to get mixed up. And usually with these, what happens is you find the first and the second is a clue about, well, you find the first and your first answer is a clue for the second. And then often the second is a clue for the third, and so on. So writing it in the simplest possible form will help you to simplify this. Also, this was a 1-point question, so it should have been rather easy. PL is a 1-point question too, but I think that's trickier. Well, what we just found was we found Q to P, right? Or P to Q. We found from here to here. Now we're being asked to find from here to here. And we know that from here to here is 2/3 of the distance from P to Q. So it's going to be 2/3 of Q minus P. That might be really clear to you, but if not, let's make sure. We're using this ratio, so we know this is 2 parts of the 3. From here to here is 2 parts of the 3 parts required to go from here to here. And in the first question, we found out how to go from P to Q. It's negative P plus Q. So we need 2/3 of that. So it's just going to be 2/3 times negative P plus Q, like that. Now, M to L. That's a little trickier. M to L. How can you go from here to here, right? Well, there's a couple ways we can do it. We could go from M to Q to L. We know that because this is negative P if we went that way, right? And we know that this would be, we could figure this out right here because we could make a combination of those 2. But here's what I think. Let's see if we can figure out how to go from here to here using this. Because we know how to go from here to here. We know how to go from P to L. So do we know how to go from M to P? Well, that's just negative Q, right? Because Q goes from here to here. This is a parallelogram, so this is parallel. It's the same length. So if we went that direction, that would be negative Q. and then add P to L. So here's what I'm saying. I'm saying M to L is going to be the same as M to P plus P to L. And we just found out what P to L was. So I'm going to go ahead and say M to P is negative Q, and P to L is 2/3 Q minus 2/3 P. So all I did right there is I went ahead and I just distributed this, right? So negative Q and negative 2/3 Q, well, sorry, negative Q and positive 2/3 Q is negative 1/3 Q minus 2/3 P. And you could simplify that in a couple different ways. You could say that's, I don't know, there's all kinds of ways you could write it. It doesn't really matter. You could factor out a 1/3, you could factor out a negative, but this is going to be sufficient right there. All right, now last one, position vector of L. Position vector of L. So position vector of L, and we have to write that in terms of P and Q, you see? So a position vector is the vector from the origin. So from here to L. Well, I think if we did that just like we considered how to get from M to L, if we went from, because we know how to go from P to L, so let's just use that. We already did that work instead of like figuring out how to go from here to here, you know, from O to Q and Q to L, instead of figuring that out, since we already, screen timed out, since we already figured out how to go from P to L, we know how to go from O to P. So let's say like this right here. Let's say position vector of L would be from O to L. So that would be from O to P, and then add that to P to L. You see? O to P is P. P to L, we already know, is 2/3 Q minus 2/3 P. So I think that's going to be 2/3 Q plus 1/3 P. Right? So let's make sure we got this right here. From here to here is P. From, oh, sorry about that. From here to here is P. Because we want to figure out how to go. Let me back all the way up. We want to figure out how to go from O to L. And it would be smart if we can use the clues we already found, especially this one right here, because we know how to go from, we know this right here. We know how to go from here to here. So if I go from O to P and then from P to L, I got it figured out. And I think that's pretty easy because I'm already using this answer. So all I have to do is add P to it, which is what we did right here. So anyway, I hope that was helpful. Hey, if not, you can send me an email. You can reach out to me in Google Classroom. You can leave a comment in the, down below. However you want to do that. Let's see. Here's what I'm going to be doing later today. I'm going to make a quick review on some algebraic fractions for you, and I'm going to email the quiz. I'm not going to try to do it in a good, especially for algebraic fractions. I'm not going to try to do that in a Google Classroom. And then I'll email you. I'll put a paper 2 and a paper 4 in Google Classroom. So I may have misspoken. The algebraic fractions quiz I'm going to put in Google Classroom today, and paper 2 and paper 4 I'll put in there as well. So anyway, I hope it's been helpful. Hope I get to see all of you guys soon. I know you can see how lovely and wonderful I look right here, but anyway, let's keep at this. Let's get ready, and I'm pretty excited about how you guys are going to do. You guys are doing really well before spring break, and you get a little rusty. I get a little rusty. We all do. So this practice is good for us. It shouldn't be overwhelming. It should be useful. It should be purposeful. It should give you something to do. Get out of your sister's hair or whatever. Anyway, hope to see you soon.